Hello, good day. So we started this whole unit talking about equilibrium, and then we got into equilibrium calculations and ice tables and equilibrium constants, and now suddenly all that is gone, and it's going to stay gone for a few lessons while we talk about acids and bases. And later in the unit, we're going to tie those things together because every time an acid or a base dissolves, it creates an equilibrium system, and we'll use the concepts from 4.1 to 4.4. But for now, put that on the shelf and try not to completely forget it while we learn about acids and bases. So, as you saw in the lessons, anytime you have an interaction where a hydrogen is exchanged, that's called an acid-base reaction, and whoever is giving away the hydrogen is considered to be an acid, and whoever receives the hydrogen or takes it is considered to be a base. So in this first pair, we have HSO3 meets H2O, and afterwards, the SO3 used to have a hydrogen and afterwards it doesn't. So the interpretation here would be that this was an acid. These met, the HSO3 said, here, have my hydrogen. Afterwards, the water has an extra hydrogen now, and the SO3 has lost it. If the H2O accepted a hydrogen, then that would mean it is a base. So here we have a giver and a taker. If this reaction were running in reverse, then we'd have the H3O starts out with a hydrogen, which it loses, so this would be considered an acid. And the SO3 would be a base because it starts out as just SO3, and afterwards, oh look, it's gained a hydrogen. So on each side of these reactions, you will have an acid or a base. If you're an acid for one reaction, then you'll be a base for the reaction going in the opposite direction. So this sulfur compound is a hydrogen giver here, or a hydrogen taker if the reaction runs the other way. Here, these two meet, and who gains a hydrogen? NH3 becomes NH4, so this gained a hydrogen, which would make it a base, and its counterpart then must be an acid. If NH3 is a base, then this is what we'd call its conjugate acid, the acid version of it when it has one extra hydrogen, and this, having lost a hydrogen, which it would like to get back, is now called a conjugate base. Okay, I suspect you get the idea, so I'll pick up the pace on the rest of these. HF going to F, so HF has a hydrogen here, then loses it. This is an acid, and this is its conjugate base. I don't want to put the conjugate in there, I'll just say base. And here we have an acid with two hydrogens, and having given one away, it becomes a base on the other side. H2SO3 is an acid because it can give away a hydrogen. Here it is missing one hydrogen, so here it is before and after. And here we have H2S with two hydrogens. That's an acid ready to give something away. And here it is as a base, having lost one of them. The acid will always have more hydrogen, and the base version will always have less. Here we have HNO2 and NO2, so this will be our acid, and that's our base. Here we have Cl and HCl. This is the acid version that could give away a hydrogen. Here's the base version that wants to take one back. And C2H3O2 is an ion, and here it is with a hydrogen on it, so this would be the acid version and the base version. And again, H2S acid, one less hydrogen would be a base. Not too bad.